So in question 11, the equation for reaction between hydrogen and chlorine is shown. H2 plus Cl2 gives 2HCl, and the reaction is exothermic. We have to calculate the energy change for this reaction. So again, for a reaction, H2 plus Cl2 gives 2HCl. So the equation is given, but we don't need equation, we need bonds. So H2 means hydrogen, hydrogen single bond is there. Cl2 means chlorine, chlorine single bond, and HCl means hydrogen and chlorine. And there are two molecules, so there will be two molecules of H and Cl. So reactant side is a bond breaking side, where the product side is a bond forming side. So the formula is bond breaking minus bond forming will give us the energy change. So the bond breaking side, because H hydrogen hydrogen is 436 plus chlorine chlorine is 240, so it will be 656. 676, not 56 by mistake. So 36 plus 40, that's 76, and 200 plus 400. So this is 476. Bond forming H and Cl, it is 430. So it will be times 2, 860 will be the bond forming. So energy change during a chemical reaction is bond breaking minus the bond forming is equals to the energy change. The bond breaking, that is 476, minus bond forming, it is 860. So when we subtract this, (676) minus 860, it will give us minus 184. So P will be the right answer. And what is the kind of this reaction? Exo or endo? What kind of reaction is this? Energy change is negative. If energy change is negative, what is the kind of reaction? So it will be exothermic. Another question related to bond energy. So N2H4 gives N2 plus 2H2. The structure of N2H4 is given hydrogen, which is a rocket fuel. So N2H4 turn into N2. Nitrogen belongs to group 5, so it will share 3 electrons. So in N2 there will be a triple bond between the two nitrogen atoms. And plus 2H2, so there are two molecules of hydrogen. So the bond breaking side and the bond forming side, the bond breaking side, because as you can see the equation, the hydrogen is a reactant and nitrogen and hydrogen are the product. So bond breaking side is for hydrogen, and what are the bonds present? There is 1, 2, 3 and 4 NH bonds are there, plus nitrogen nitrogen single bond. N triple bonded with N, that's a bond forming. plus hydrogen single bonds are there, and how many of them? 1 and 2. So this will be 2. So 4 NH bond, so 4 multiplied by 390 plus nitrogen single bond, that is 160. So this will give us the bond breaking. And what about bond forming? Nitrogen triple bond is there, that is 945 plus 2 hydrogen single bond, that is 436. So when we solve 390 times 4 plus 160, that is 1720. Bond forming, that is 2 multiplied by 436 plus 945 equal to 1817. To calculate the energy change, it is bond breaking minus bond forming, that will give us the energy change. So bond breaking is 1720, bond forming is 1817. This will give us minus 97 kilojoule per mole. So if you are getting a negative answer, it means the reaction is exothermic and it is already mentioned. And whenever something is used as the fuel, the reaction must be exothermic so that it releases energy. So the final answer is equals to minus 97 kilojoule per mole. Another question. So you will find the same pattern is there, same way we calculate. If it's always the bond breaking minus bond forming, which give us the energy change. So what is the energy change? So to get the energy change, equation is given. When equation is given, the first step is you represent the bonds. H2 means hydrogen bond is there. O2 means oxygen double bonded with oxygen. And that H2O means H, oxygen, and then H. And there are two molecules, so there will be two molecules of H, O, and H. So reactant side is a bond breaking side, whereas the product side is a bond forming. So bond breaking, hydrogen bonds are breaking. How many of them? Two of them. Plus O double bonded with O. And bond forming 1, 2, 3, 4. So there are 4 OH bonds are there. When we substitute the value for hydrogen, it is 436 plus oxygen double bonded with oxygen 496. And for 4 OH bond, 1, 2, 3, 4, each OH bond or HO bond, it is 460. So it will be 460. When we solve, so it is 436 times 2, 872 plus 496. So 872 plus 496, that is 1368. And the bond forming, that is 4 multiplied by 460, that is 1840. And the bond breaking minus bond forming, So 1368 minus 1840. So energy change will be minus 472. So C will be the answer as the reaction is exothermic. Is it clear? Discussion? Anyone having a doubt till this point? So another question, we have to calculate the energy change. Methane is there. Methane is there reacting with oxygen. This one I want everyone to solve and state the right answer. I will show the bond. So methane is there, which is CH4. Oxygen is there, O double bonded with O. This is a bond breaking and bond forming. CO2 means oxygen double bonded with another oxygen carbon and with another carbon, and H2O, H, O and H. So this side is a bond breaking, sorry, bond forming, and this side is a bond breaking. I want everyone to calculate the energy change. The values are given. You just have to substitute the values and state the right answer. Use the chat to state the right answer. I'm waiting for your response. So how D is the right answer? Because the bond breaking minus bond forming. The bond breaking 1, 2, 3, 4 CH bonds are there. So it will be 4 multiplied by 410. And oxygen double bond, that is 496. And bond forming energy, O double bonded with C, that is 805. So it will be 2 multiplied. Why 2 multiplied? Because 1 and 2 bonds are there. And plus OH bond 1, 2, 3 and 4 OH bonds are there. So it will be 4 multiplied by OH, and that is 460. Then we calculate the bond breaking and bond forming and take the difference. It will come out as 818 kilojoule per mole. That's a unit of energy, bond energy, which is kilojoule per mole. Another question, hydrogen peroxide. The formula of hydrogen peroxide is given, decompose to water, form water and oxygen. What is the energy change for this reaction? So two molecules of hydrogen peroxide, H, O, O and H, and then H, O, O and H, and form water molecule. Water molecule is HOH, and two water molecules, so H, O and H, and oxygen is there, so O double bonded with O. Bond breaking, and this one is bond forming. So what is the energy change? The bond breaking minus bond forming. What is the right answer for this question? So we have 1, 2, 3 and 4 OH bonds for bond breaking. And we have 1 and 2 oxygen single bonded with oxygen. So it will be 4 into OH 460 plus oxygen single bonded with oxygen. So 2 are there. So it will be 2 into 150. And for bond forming 1, 2, 3 and 4. So 4 OH bonds are there, or HO bonds. And there is one O double bonded with O. So 460 multiplied by 4 equal to 1840 plus 300. So the bond breaking energy is 2140. Bond forming, it is 4 into OH, that is 460 plus oxygen double bonded with oxygen 496. So 4 multiplied by 460 plus a molecule of oxygen is there, that is 496. So it is 2336 minus 2140. So answer will be negative. The energy change bond breaking is minus 196 kilojoule per mole. And as they mentioned, exothermic, so C and D cannot be an answer because they are positive, so it can be A or B. So that's why B, when we calculate, B is the right answer. So these are some questions related to the chemical energetics. The next session will discuss more questions related to the topic.